Alright, we are starting chapter 3, so we're going to start with 3.1 exponential functions. Our essential questions are, what does an exponential function represent? So what is it? What does it mean? And what are the characteristics of a graph of an exponential function? So, a definition of an exponential function. The exponential function of f with base b is defined by f of x equals b to the x power, or y equals b to the x, where b is a positive constant other than 1, so b cannot equal 1, b is greater than 0, and b does not equal 1. So it's a positive number, not 1, but greater. If it's positive, it's greater than 0, and it just can't equal 1. X is any real number. So the exponential function f of x equals 42.2 times 1.56 to the x power. Models the average amount spent, f of x in dollars, at a shopping mall after x hours. What is the average amount spent to the nearest dollar after 3 hours of shopping at the mall? So we're going to substitute 3 in for x and evaluate the function. So this means we have f to the 3 equals 42.2 times 1.56 to the third power. So if you were to plug this into a calculator, you would want to do 1.56 to the third and then multiply what you get by 42.2. And you get about $160.21. So after 3 hours in the mall, on average, you would spend $160.21. So if we look at a graph of this, we set up a table of coordinates, then plot these points. So you have f of x equals 3 to the x. Negative 2, you get 1/9. Negative 1, you'd get 1/3. 0, you'd get 1. And 1, you would have 3. So we plot our points. Set up a table of coordinates and plot these points, connecting them with a smooth, continuous curve. So, some characteristics of exponential functions in the form f of x equals b to the x. Domain of f of x equals b to the x is all real numbers, so it's negative infinity to infinity. The range is going to be positive real numbers, 0 to infinity. The graph is going to pass through the point 0, 1, because f of 0 is always going to be 1. So no matter when you raise something to the 0 power, it equals 1. Y-intercept is 1, and there is no x-intercept. It will never cross your x-axis. So if b is greater than 1, then the graph that goes up to the right is increasing. The greater the value of b, the steeper the increase. If b is between 0 and 1, the graph goes down to the right and is decreasing function. The smaller the value of b, the steeper the decrease. The graph f of x equals b to the x is a 1-to-1 and has an inverse of that is a function. The graph of f of x equals b to the x approaches but does not touch the x-axis. The x-axis, or y equals 0, is a horizontal asymptote. So use the graph of f of x equals 3 to the x to obtain the graph g of x equals 3 to the x minus 1. So we had just graphed on the other slide f of x equals 3 to the x. So we've defined 3 points and the asymptote. You have a horizontal asymptote, y equals 0, and you have the point 1, 3, 0, 1, and negative 1, 1/3. So you want to think about what's going to happen if I have x minus 1. Think about your quadratic and your polynomial functions. So the graph will shift 1 unit to the right. So you're going to add 1 to each x coordinate. Since you didn't shift up or down at all, your horizontal asymptote is still going to be y equals 0, but all your points are going to shift to the right. So instead of 0, 1, you're going to have 1, 1. Instead of 1, 3, you're going to have 2, 3. Instead of negative 1, 1/3, you're going to have 0, 1/3. Make sure you complete the questions below, watch the next video, and next time we're going to talk about functions with base e and compound interest formulas.